You what?
Do you mind if I charge my phone?
No, okay. All right, so yesterday we started and we did section 1.1, which I kind of rushed through because of the whole going over the syllabus. So if there were homework problems that you tried in section 1.1 and couldn't match up your answer with my answer, then I should try to make that better. On like problems like 11, 13, and 19, there are probably multiple correct answers depending on whether you took the time to write the term with a negative first or if you left the problem in the order that it's written. So like if you did problem 19 in section 2.1, and if this was a test question that had the same instructions, section 1.1, wrong class. Number 19 asks me to factor out the opposite of the greatest common factor. When I see the word factor out the opposite, that means to factor out, that implies to factor out a negative. So immediately the instructions imply to me that I want to have a negative in front of a parentheses. And then even more than that, they probably imply there's more than just a 1 or more than just a negative sign. And the extra that I'm going to factor out is a 3 because both 6 and 3 are divisible by 3. So I'll write a negative sign because of the word opposite, a 3 because the greatest common factor is a 3. And then I'll divide each of the numbers by 3. But before I get my numbers dealt with, I'm going to deal with my signs. When I factor out a negative, that factoring causes my signs to change. Because there was no sign in front of the 6, I'm going to change the sign from no sign to a negative sign. If no sign is there, there's an implied positive. I'm going to flip it to negative. Between the 6 and the 3z, there was a minus. When I factor out a minus, I flip the signs. I'll flip that sign to plus. Now I'll get the right numbers and letters in. For each of the numbers, I'm going to divide by 3. 6 divided by 3 is 2. There wasn't an x written first, so there's no need to have, or there wasn't a letter in the first position, so there's no letter that goes with the 2. And in the next piece, I'm just going to write a z because I'm going to divide the 3 that I had in the original problem by the 3 that I factored out, and I get a 1. I could write a 1 in front of the z, but a z without a 1 is probably better. So this is a correct answer, but not the only correct answer. It's probably not even the best correct answer. Probably when I wrote my key for this section, I probably took the time to rewrite it with the negative first because it's odd to ask you to factor out a negative or an opposite if the negative's not written first. So I could have rewritten this problem with the negative 3z first and the 6 second. If I wrote it with the 6 second and the 3z first, the 3z had a negative in front of it in the original problem. That negative needs to stay there. The 6 didn't have a sign, but I need a sign to separate the two. It wouldn't make sense to put a minus because there isn't a minus in front of the 6, so I'd put a plus there. And I'll still factor out the same negative 3. It probably would be nice if I put an equal sign because this equals the line above it, and what I write here is going to equal the line above it. I'm going to factor out the same negative 3. Make my parentheses. This negative sign should turn to positive, but when a sign's first, I'm just not going to write a positive. But it flips to positive, and positive is just a no sign when something's first, and this positive is going to turn to negative. So the signs I'm going to have are no sign to represent a positive, and then a negative to flip that positive. And I'll just divide the numbers by 3 again. 3 divided by 3 gives me a 1 in front of the z. I don't need to write the 1, but I could write the 1 in front of the z. And 6 divided by 3 is 2. So both these answers are correct. Whether you do or don't have the 1 in front of the z, that doesn't make it any less or more correct. It's just a matter of preference. Usually you don't write the number in front of the letter if it's a 1, but it's not wrong to write it. I don't know if that was a thing of beauty or not, but hopefully that's okay. Are there any other problems in section 1 that you want to look at? It's not a bad thing. I mean, it's not. Hopefully, it wasn't the worst homework that we had. We might progressively get a little bit harder. I'm gonna, before I get into section 1.2, I'm gonna do, I don't probably 12 problems just to warm us up for the section. Because my problems are good, but my problems are written in such a way that it doesn't fix the problems that a lot of students have. And a lot of students have issues when you're factoring trinomials with signs. And so this is extra free bonus coverage here. So this is extra. This is not in the handout. And it's just to help you, if you're not already comfortable factoring trinomials and knowing what to do with the signs. It's 7:15 today, Aaron. Yesterday I understood, but today that's not good. So these two problems ask me to factor, and this is the kind of factoring where you get two parentheses as opposed to just a common factor. There's not a common factor at all in either of these problems. There's not a common factor of an x because each of the three terms doesn't have an x. And there isn't a number that's a GCF because there's not a number in front of the x squared. Each one of these is going to factor similarly. These are two separate problems, but I want to put them next to each other because they factor the same. For both of these, I'm going to factor into two parentheses. I can put an equal sign because what I'm going to write is going to equal a line above it. And for both of these, the signs are going to be plus and minus. If in a factoring problem, if the second sign is minus, when this is minus, the signs in the parentheses are plus and minus. So when I go to factor this, one parenthesis is going to have a plus, another parenthesis is going to have a minus. Similarly, when the second sign is minus, my parentheses factor with one plus and one minus. So always when I go to factor trinomials, well, first I look for common factors. So my steps for this are factor out the GCF or a negative if necessary. Neither one of these problems, which are two different problems, have a GCF, so I'm not going to worry about them. After I deal with that step, which in this case involved doing nothing, as I'm going to make my parentheses with my signs. Because that's easy enough to do. The third thing I'm going to do is put my firsts in because my firsts are generally pretty easy. And not normally an area where students get messed up. Because there's not a number in front of either the x squared, when I go to factor these, I just need the x squareds are in the first position. I need to split that x squared into a pair of x's into the first positions. So in each one of these, which are two different problems, but they look similar, the first three steps look identical. There's no GCF, so I don't have to worry about it. Made my parentheses. The signs are the same. If the sign in the original problem has a minus written second, the signs are a plus and minus. Firsts aren't so hard because the firsts are the same. It's the lasts that are going to be the thing that messes me up. So I'm going to place my lasts. And for each one of these problems, my lasts have to do similar things. They have to multiply to be the last number, and they have to subtract to be the middle number. And I have to be careful when I have one sign plus and one side minus. I can go horribly wrong by putting the numbers in the wrong spot. So I have my signs. I'm not going to worry about signs anymore. When I go to place my lasts in this first column, my lasts are going to have do three things. First, they're going to need to multiply to be that last number. That last number is 6. I'm not going to worry about signs because I already have the signs in. for this particular problem, whatever I put into my last position, they have to subtract to be the middle number. In this case, the middle number is 5. And because because the 5 is positive, the bigger of the numbers need to be positive. So real quickly, this is easy for me to figure out the last. The last is just going to be 6 and 1, because 6 times 1 is 6. 6 minus 1 is 5. So there's the numbers that go in my lasts are 6 and 1. When the signs are opposite, I can go wrong and put the numbers in the wrong spot. Because the 5 is positive, the bigger of my lasts needs to get tagged with the positive. So for this particular problem, my lasts are going to have a positive 6 and a negative 1, as opposed to a positive 1 and a negative 6. That's done. I'll check it in a second. This version over here of the problem that's almost the same but just subtly different, when I go to find the lasts for it, it's almost the exact same instructions. My lasts are going to, this time they're going to multiply to that last number 6. I'm going to say they're going to subtract to be the middle number, and the middle number is negative 5. And to get the negative to happen, the bigger of the pair needs to be negative. So same sort of deal. The numbers are going to be 1 and 6 again, because 1 times 6 is 6. They need to subtract to be negative 5, and 1 minus 6 is negative 5. So when I go to place my last, it's the same last. It's essentially the same problem. The difference between this problem and this problem is here, the middle number is positive, so the 6 needed to be positive, which is the bigger of the 6 and the 1. This problem right here, the 6 needs to be negative to make the 5 negative. So when I go to place my numbers in, I'm going to get a positive 1 and a negative 6. So the difference between these two problems is where the lasts go. When the first sign, when the middle term is positive, the bigger number goes with the positive, the smaller goes with the negative. When the middle number is negative, the bigger last gets with the negative. I can check each of these just to show you that it works. So I'll try to sneak that in here. For each one of these, I could stop and be done. This is the answer to the first factoring problem. And this is the answer to the second factoring problem. Anytime you factor into 2 parentheses, you can check by foiling. So I'm going to go ahead and check each of these to show you that it actually works. So I'm going to check by foiling. The first one, if I'm trying to check my answer, I'll do the firsts, which are x times x, and x times x is x squared. I'll do my outers. My outers are x times minus 1. Positive times a negative is a negative. I don't have to write the 1 in front of the x. I can write just a minus x, or I could write a minus 1x, depending on what I prefer. The inners are positive 6 times x. They're both positive, so I get a plus. I leave the 6 and the x next to each other. I don't need a parentheses. And the lasts are 6 times negative 1. Positive times negative is a negative, and I write 6 times 1, which is 6. Now I'm going to combine the outers and the inners, and this is where the subtraction part of this is important, because when I combine those outers and inners into a single term, because the numbers in front have opposite signs, to combine the two terms together, you subtract and take the sign of the larger. So I'm going to bring down the x squared. These terms right here, the 6 and the 1 have opposite signs. I subtract to get the sign of the larger, so I get a positive 5x, and I bring down the minus 6, which is perfectly the original problem, so my answer is correct. If I do the same sort of checking for the next one, which is a separate problem, but that's similar, I do my firsts, which is x times x, which is x squared. My outers are x times minus 6, which is a minus 6x. My inners, 1 times x, which is a positive 1x. And my last, 1 times negative 6 is a negative 6. And just like the last, when you're foiling, you generally, the outers and the inners can be combined. And when I combine the outers and the inners, I'm subtracting because the outers and the inners have different signs. And when you have terms with different signs that you're combining, you're going to subtract. And in this case, I'm going to bring down the x squared. The 6 and the 1 have opposite signs. I subtract. I take the sign of the larger, which is the negative, and I get a negative 5x. And I bring down the minus 6. Because that's exactly the original problem, I factored properly. So it's hugely important to be able to differentiate between problems that almost look the same, but they aren't the same because they factor differently. And so often students just choke on the sign. So I'm going to write down a few more pairs and see what you can do in terms of factoring them. So I'm assuming you have some knowledge of factoring. This is in some sense review, but it might not be. So this is more extra problems that aren't in the handout, just to get the signs down. So how about x squared plus 2x minus 8 and x squared minus 2x minus 8 and x squared plus 5x minus 24 and x squared minus 5x minus 24. So these are, again, in groups. I paired the problems just to illustrate what's important here. Every one of these problems, when you go to factor it, they're all going to have the same firsts as a couple of x's. They're all going to have signs of plus and minus. It's just a matter of getting the right lasts. So every problem that I write down, every answer that I write down, the firsts are going to be x and x. The signs are going to be plus and minus. It's just a matter of getting the correct lasts. And the top two are going to have the same last, maybe just in different positions. The bottom two are going to have the same last, just in different positions. So mindlessly, I could write the first down. They're all x and x in each because there's not a number in front of the x squared. And mindlessly, I can write the signs down because if the second sign in the problem is a minus, the signs in your answer are plus and minus. Now it's just a matter of getting the lasts. And each of the lasts have to multiply to the last number, subtract to the middle number. It's just a matter of getting the right signs. So So the first two problems, the last have to multiply to 8 and subtract to 2. The last two problems, the last have to multiply to 24 and subtract to 5 because the last number is 8, the middle number is 2. And then it's just a matter of knowing where to put the numbers because the numbers hopefully aren't horribly hard to find. What numbers are the pairs that I need for the first pair? 2 and 4, because 4 times. So the numbers that I'm searching for each one of these are 4 and 2, because 4 times 2 is 8 and 4 minus 2 is 2. So those are the two numbers. I just need to get them in the right spot. And for the top one, which one gets the plus?
4.
The 4. Because this 2 is positive, the bigger number gets tagged with the positive. So it's going to be a plus 4 and a minus 2. And then in the second one, it's going to go opposite. Because the 2 is negative, the bigger number needs to get pegged with the negative. So it's going to be 2 and 4. So the difference between these two problems is where the numbers go. There's two numbers, 4 and 2. When the first term is positive, the bigger number gets attached to the positive. When the first sign is negative, the bigger number gets attached to where the negative is. So it's a huge deal to be able to get the numbers in the right spot because you'll start losing gobs of points if you can't make that subtle difference. So the problems are essentially the same but subtly different. Similarly, these two problems are essentially the same problems. My answers almost look identical, but they're not completely identical because the 5x's have different signs. Hopefully you figured out the numbers were 8 and 3, because 8 times 3 is 24, and 8 minus 3 is 5. So those are the numbers I need. Now I just need to get them in the right spot. In the first one, where does the 8 go? The 8 goes with the plus. Because the plus is with this number, the bigger the number needs to get the plus. So I get a plus 8 and a minus 3. And then it's going to be the opposite in the next one. In the next one, because the 5 has a negative, the 8 has to get the negative. Because the bigger number needs to get this sign. In this one, the bigger number is 8. It needs to have a plus sign. Here, the bigger number is still 8. Now it needs to get the minus sign. So I'm going to get a plus 3 and a minus 8. So that's the most confusing part of factoring trinomials when you don't have numbers in front of the x squared, is just getting the lasts set up properly. So hopefully that's the beginnings of getting lasts done well, but not the entirety. This is the harder part of getting the lasts. There are other sets of problems that look alike and factor alike, but they're slightly different. So these pairs of problems, how about this? X squared minus 6x plus 5 compared to x squared plus 6x plus 5. These are a pair of problems that are going to factor very similarly. They're easier to factor. And when I look at a problem, I always like to get my signs in my first in as quickly as possible. When the last is plus, so when the second sign is plus, both parentheses have the same sign. This is different. The other 6 problems that I did, this sign here was minus. When that sign is minus, you get 1 plus and 1 minus. So for these problems, if I'm going to go to factor them, I'm going to make 2 parentheses. Then I'm going to get my signs. The first one, the signs have to be both minus, because the signs have to be the same to make the last come out to be a plus. And because there's a minus sign, I need to insert a minus sign. This version right here, since there's no minus signs in the problem, it's nothing but pluses. The nice thing about both sets of problems here is I can't go wrong with my lasts. If I get the right lasts, they can go in either parentheses and they'll be okay. It's only when you have 1 plus and 1 minus that the lasts are picky. So for each one of these, my firsts are easy. I'm going to split the x squared between the 2 parentheses. And the lasts are actually easy. Here, for each one of these, my lasts have to multiply to the last number 5, and they have to add to the middle number 6, and it doesn't matter where I put them. I can't go wrong here. Whereas in the last problems, if you reverse the numbers, you'd get them wrong. The numbers are going to be 5 and 1 or 1 and 5. So for this problem, it would be correct to write x minus 5 times x minus 1, or x minus 1 times x minus 5. Similarly, for the first problem, or for this second column problem, it would be correct to write either x plus 1, x plus 5, or x plus 5, x plus 1. When the parentheses have the same signs, bad things can't happen. Your numbers can go in either parentheses. I'll check these just to show you that they actually check. For checking, I'm going to go by foiling. I'll check this one just because it's just sitting here for me. But these are both correct answers. When I go to check, I FOIL. My firsts are x times x, which is x squared. My outers are x times minus 5, positive times the negative's a negative. I leave the 5 and the x written next to each other. So I get a minus 5x. My inners are minus 1 times x, positive times a negative is a negative. I don't need to write the 1, but I'll leave it. I'll write the 1 and the x next to each other. And my lasts are negative 1 times negative 5. And I'm going to get a positive 5 for that. Just like when I checked the last few problems, when I FOIL, the outers and the inners usually combine together. In the last few checkings that I did, the numbers had opposite signs, so I subtracted. Here, the numbers have the same sign, so I add and keep the sign. So when I combine the outers and the inners in this case, this is why I'm adding, because I'm adding when I'm combining these, because they have the same signs, they don't have opposite signs. Negative 5x and negative 1x is negative 6x. Because that's exactly the original problem, my answer checks perfectly. If I went to check this version or that version of this, it's going to FOIL out just right too. So if I wanted to check this one, I can check by FOILing. My first are x times x, which is x squared. My outers are x times 5, which is a positive 5x. My inners are 1 times x, which is a positive 1x. And my lasts are 1 times 5, which is a positive 5. Generally, when I check by FOILing, the outers and the inners combine. If the outers and the inners have opposite signs, you're subtracting to combine them. Since the outers and the inners here have the same signs, I add to combine them, and 5x plus 1x is 6x. And since that's the same as the original problem, that answer is correct. But both these answers here that I didn't check are also correct. So when the signs are the same, you can't go wrong. Both versions are okay. So let me quickly write a few problems down for you to just do. How about this? I'll use y for a difference. Y squared minus 10y plus 24. And then y squared plus 10y plus 24. And I'll do as, d squared minus 15d plus 36. And d squared plus 15d plus 36. So these are all paired problems, whereas they both essentially factor the same way. The signs are going to be slightly different, but the numbers are going to be the same, just like the problems I made with the pluses and the minus that had the numbers the same, but the signs kind of a little bit different. That's the case here. Every one of these, because if I look at the problem, the second sign is a plus, the parentheses have to have the same signs. So I wrote down what my lasts need to do, and it just doesn't matter. Once you get the right lasts, it doesn't matter which parentheses you put them in. It only matters when you have one sign plus and one side minus, where the lasts go. Lynn, feeling good about the very first one? What are your lasts? 2 and 12. What did 2 and 12 subtract to be 10? So that's not. If you FOILed yours with 2 and 12, so you said this. You said it's y minus 2 times y minus 12. If I tried to FOIL this, my first would be y times y, which is y squared. My outers would be y times minus 12, which is minus 12y. My inners would be minus 2 times y, which is minus 2y. And my last would be minus 2 times minus 12, which would be plus 24. These terms, these outers and inners, are going to combine to a minus 14. This is going to be y squared minus 14y plus 24, because when I'm combining the outers and the inners, because they have the same signs, I'm adding them, I'm not subtracting them. So the numbers you got, 12 and 2, they do give you a 10, but they subtract a 10. They don't add to 10. So they're not the right pair for this. There's another pair of numbers that multiply to 24, but add to 10. These 12 and 2 add to 14, so that's why they weren't right. 6 and 4 are the pair that I need, because 6 times 4 is 24, and 6 plus 4 is 10. And it wouldn't matter if I wrote y minus 4 times y minus 6 down either. And then if you had in your parentheses like y plus 2, y minus 12, that also would be wrong because the last would be a minus 24. So it's very specific. The signs are fixed on me. I can't make my own signs up. I couldn't have made this have 1 minus and 1 plus because that won't work. And the last have to add and not subtract. The next one, the signs are also going to be 6 and the numbers are also going to be 6 and 4 because look at the numbers are doing the same thing. They're multiplying to 24 and adding to 10. And it certainly wouldn't matter if I would have put in y plus 4 times y plus 6. So the last two are going to have the same numbers because the lasts are doing the same thing. They're multiplying to 36 and adding to 15. So if you can factor the bottom one, you can factor the one above it because they have the same numbers. Harder numbers, though. 12 and 3. 12 times 3 is 36, and 12 plus 3 is 15. So it doesn't matter where I put the 3 and the 12. I can put the 12 in the first parentheses, the 3 in the second parentheses, or the 3 in the first parentheses, the 12 in the second parentheses. When the signs are the same, numbers, it's not a deal breaker if you mess up on, you can't mess up. So very important is to know what the signs are. Generally, I make a little template like this. I do this, I say original signs. Parenthesis signs. And then, I'll say keyword. And there's only 4 possibilities for the original signs. The easiest situation is if the original problem has both plus signs. That's like a few of the problems on this last page. The y squared plus 10y plus 24, the d squared plus 15d plus 36. Those are problems that the original problem has nothing but plus signs. My parentheses are each going to have plus signs in that case. And I'm adding my factors to get the middle number, so I'm going to say I'm going to add to get the middle number as opposed to subtracting to get the middle number. Because my 12 and 3 had to add to 15. My 12 and my 3 had to add to 15 and multiply to 36. My 6 and 4 had to multiply to 24 and add to 10. So that's one possibility. The other possibility that leads to same signs is if the original problem had a minus first and a plus second. That's like the y squared minus 10y plus 24, the d squared minus 15d plus 36. When that's the case, my parentheses both have minus signs, and I'm still adding my lasts. I'm finding numbers that multiply to the last but add to the middle. The first scenarios that I looked at had minuses written second. And if a minus is written second, you get 1 plus and 1 minus every time. And you're subtracting to get the middle term. And then when you have signs 1 plus and 1 minus, you can go wrong by putting the number in the wrong parentheses. So it's important to know which number gets tagged with the plus and which number goes in front of the minus. So hopefully with that warm-up, we can get into the problems in section 1.2 and just kind of cruise right through them. Hopefully you didn't even need the warm-up to actually get into the problems. This is theoretically review. If it doesn't feel like review, hopefully I didn't do it so fast that I kind of ate you up. So hopefully this is not a horrible thing. If factoring is tough for you, you need to perfect it because this chapter 1 and chapter 2 are basically all factoring problems. You factor and you do something, or you just factor and stop. So the problems in section 1.2 only ask me to factor. So I'm going to factor and stop. I'm not going to set my factors equal to 0. So if I'm asked to factor a generic problem, I like that has 3 terms without a common factor. I like to make my parentheses and throw my first in because that's generally easy for me. And it's just getting the last that takes a little bit of effort. So my template's going to tell me that this problem starts with a plus and a minus. My parentheses is going to have a plus and a minus. I'm subtracting to get the middle term. When the signs are different, I have to be careful to get the numbers in the right place. So I know without any thought that my firsts are a couple of y's to give me my y squared. My templated signs tell me it's plus and minus. And now my lasts have to do a couple things. They have to multiply to that last number, which is 50. They have to subtract to the middle number, that's 5. And because that 5 is positive, the bigger number of the pair is going to get the plus. So what are the lasts? 10 and 5, because 10 times 5 is 50. 10 minus 5 is 5. And when I'm putting numbers in that have opposite signs, I can go wrong. If I put the 5 in the first parentheses, that would be wrong. Because this sign is plus, the bigger number needs to get the plus. So the 10's going to have the plus, and the 5's going to have the minus. I'm done. I could check by foiling. So I could stop right now. I can foil to check if I cared to. That wouldn't be wrong. But it would be wrong to do this. To go y plus 10 equal to 0, y minus 5 equal to 0, minus 10 minus 10, y equal to minus 10, plus 5, y equal to 5. That would be horribly wrong to do. The only time you do this, if you remember this from some previous class, is when the problem has an equal sign and it's equal to 0. So because every problem in section 1.2 is missing an equal sign, it's wrong to factor it and then set the factors equal to 0. And if this was a test question and the instruction said factor, and you factored and factored it right and then did this, you're going to lose points. So you don't set the factors equal to 0 unless the problems have equal signs, and that's going to come up when we get to section 1.6. In section 1.6, each of the problems are going to have numerical answers like x or y equal to some number. But because the problems in this section don't have equal signs, I'm just going to factor and stop. Check by foiling if I care to, but I don't even do that often. So hopefully I can just kind of buzz through a few of these even problems. And I won't check too many just because it takes more time to check than I really have to give. So this says b squared plus 6b plus 9, whether it looks like it or not. Hopefully you have the handout in front of you, which is probably written better than I can write. So first thing I do is make my 2 parentheses. I put my firsts and my signs in. And then magically I'm supposed to know what the lasts need to do. What did you get, Tori?
3.
3 and 3, yeah. The lasts need to be 3 and 3. So when I go to factor this, it'd be nice if I write an equal sign because what I'm writing is going to equal what's above it. My first are a couple of b's, which I just split the b squared between the 2 parentheses. My signs are a couple of pluses, and it's just a matter of getting the right lasts. And the lasts in this case, they have to multiply to the last number, 9. They have to add to the middle number, 6, and that's just 3 and 3, because 3 times 3 is 9 and 3 plus 3 is 6. Can hardly go wrong when they're the same number. This is a correct answer. It's not the only correct answer. Anybody write the answer differently? When you have 2 identical factors written next to each other, you can write it with an exponent.
B plus 3 squared.
Thank you. So it's, yeah, this would also be correct. So a b plus 3 with an exponent of 2 outside of it means b plus 3 squared. The exponent 2 means to multiply b plus 3 by itself 2 times. So both of those are correct answers. So as quickly as I wrote down the problem, I was able to write the parentheses with the correct signs and the correct firsts. The only thing I have to do is figure out what the lasts are. And my lasts have to multiply. Apply to 36. And add to 13. And you can't go wrong. Once you get the numbers, it doesn't matter which parentheses you put them in. Alvin, get anything?
4 and 3.
Yeah, sorry.
9 and 4.
9 and 4 is perfect because 9 times 4 is 36, 9 plus 4 is 13. And both of these would be correct. There isn't one version of this answer that's better than another. If you wrote x plus 9 times x plus 4, or if you wrote x plus 4 times x plus 9, those are both correct. They both foil out to be the original problem. Cool. Perfection. So I'll just keep mushing through these. It's really just getting the lasts. That's the challenging part. So the template should tell you what the signs have to be and how you need to get the lasts. So from that sheet that I gave with the little template, I know that the signs here are going to be double minus. And it's my best case when the signs are either both minus or both pluses, then it doesn't matter where I put the lasts. I can't go wrong. As long as I get the right numbers, they can fit anywhere. Manuel, what'd you get?
Yeah, I wrote it down.
Okay. I'll give you a minute. So your lasts have to multiply. 4 and 3 is perfect because 4 times 3 is 12 and 4 plus 3 is 7. My lasts have to multiply to 12, add to the middle number 7, and 4 and 3 is perfect. And it's just as correct to write z minus 4 times z minus 3 as it is z minus 3 times z minus 4. Both of those are perfectly correct. Ten's the first one in this section where you can go wrong by putting the numbers in the wrong spot because of the first one that I'm doing that has opposite numbers, opposite signs. So since the signs are different, my lasts have to subtract to be the middle number. Now I'm not looking for adding. So it would be wrong if you put 2 and 3 because 2 and 3 add to 5. They don't subtract to 5. So it's real important when you're putting your last in to know whether you're adding to get the middle term or subtracting to get the middle term because you'll get different numbers. Because for 6, 2 times 3 is 6. They add to 5. 6 minus 1 is 5. 6 and 1 multiply to 6 and subtract to 5. So you have to decide whether the 2 and 3, which kind of give you a 5, and a 6 and a 1 also give you a 5. You have to decide which pair is correct, and that depends on whether you're adding or subtracting. So what are the correct numbers here?
6 and 1.
6 and 1. And because this sign is negative, where does the 6 go? By the plus or by the minus? By the minus. So 6 and 1 are the correct numbers. Because the bigger number is minus, because the 5 is minus, the bigger number 6 needs to have the minus. So if you put the 6 with a plus, it'd be wrong. So I can write an equal sign, and that's the answer. Yeah, another correct answer would be y minus 6 times y plus 1. As long as you have a minus next to the 6 and a plus next to the 1, it doesn't really have to be that the plus is first and the minus is in the second parentheses, but I generally do it that way. 12 is tricky. So 12 gives me y squared plus 5y plus 11. I know that my firsts are a couple of y's. I know that my signs are a couple of pluses. My lasts need to multiply to 11 and add to 5. And this is there aren't any numbers that if you can't find lasts that need to do what they have to do, then it's prime. The only numbers that multiply to 11 are 11 and 1. The 11 and 1 add to 12, not 5. This isn't going to factor. It's not possible. When you can't find a pair of numbers that need to do what the lasts need to do, you call it prime. Because there aren't two numbers that simultaneously multiply to 11 and add to 5. It's just not factorable. So that's called a prime polynomial, a prime trinomial. And for 14, my lasts have to multiply to 7 and multiply to 3 and subtract to be 7. That's also not possible. The only numbers that multiply to 3 are 1 and 3. And 1 minus 3 is not 7. 1 minus 3 is 2, or 3 minus 1 is 2. So it's impossible to find a pair of numbers that multiply to 3 and subtract to 7, because the only numbers that multiply to 3 are 3 and 1, and 3 and 1 subtract to be 2. I don't see a 7 anywhere there. So those are prime. So both 12 and 14 are prime. Probably when you go to do your homework, both 11 and 13 will probably be prime. Generally, my odd problems have similar tricks as even problems. The last group of problems from 15 through 30, the instructions say to factor out a negative or factor out the greatest common factor and then factor what's left. So each of the problems between 15 and 30 I'm going to first either factor out a negative 1 or a negative, or factor out the GCF, and then second, factor what's left. So if I look at a problem like 16, if I try to factor it the way it's written, my template signs are only appropriate when the first term is positive. Because the first term here is written as a negative, it's not going to give me the correct answer if I make two parentheses, one with a double minus. My template only works when the first term is negative, not negative. So my step 1 right here is I'm going to factor out a negative 1. And we did that yesterday in class. When I factor out a negative 1, I write a parentheses next to it, and then I have to put something inside the parentheses that is appropriate. And that has to do with getting the right signs. When you factor out a negative or a negative 1, it causes the signs to flip. The negative in front of the y squared would flip to positive, but I generally don't write a positive if it's first, so I'm going to write a positive y squared. The negative that was in front of the y is going to flip to positive, and the positive that was in front of the 30 is going to flip to negative. So that's the beginnings of this problem 16. I factored out my greatest common, factored out my negative because the first term was written negative. The negative 1 that is part of the answer isn't going to impact the factoring anymore. What I need to do now is factor what's left inside the parentheses, and what's left inside the parentheses is y squared plus y minus 30. I'm going to carry the negative 1 down. It's going to be part of my answer, but it won't be part of the factoring anymore. So now when I factor that y squared plus y minus 30, I'll pretend that the negative 1 is not even there when I go to factor this. So I'm going to make my two parentheses. I'm going to split the y squared between the two parentheses. I'm going to put my signs of plus and minus in. And then I have to figure out what the lasts need to do and then what the appropriate lasts are. So the lasts need to multiply to 30, subtract to 1. What'd you get, Amanda? All right, and anybody want to help her? 6 and 5. My last are going to be 6 and 5 because 6 times 5 is 30. 6 minus 5 is 1. The bigger needs to be positive to make the y positive. So this is the correct answer, and I'll actually check it for you just to show you a way to check this. So this is the answer, and I could stop. If I want to check this, it's kind of a nuisance to check, but I'll check it. To check this, I'm going to multiply from left to right. I'm going to multiply the negative 1 into the parentheses that it's next to. So I'm going to go negative 1 times y and negative 1 times 6. For the negative 1 times y, I can write a negative y, or I can leave the 1 there. I'm going to write a negative 1y. For the negative 1 times 6, I'm going to write a negative 6. I'm done with the negative 1. It doesn't get pushed into the next parentheses. That's the beginnings of my checking. I work from left to right. I do the first multiplication that I see. That negative 1 gets gobbled up by the first parentheses, and it is gone now. And now I'm going to FOIL. My foiling is going to give me a negative 1y times a y. And when I do that multiplication, I just multiply the y's together and leave the negative 1. That gives me a negative 1y squared. The outers in my checking are a negative 1y times a negative 5. A negative times a negative is a positive. 1 times 5 is 5, and I leave the y there. That gives me a plus 5y. My inners are negative 6 times y. Positive times a negative is a negative. I write the 6 and the y next to each other. And my lasts are negative 6 times a negative 5. Negative times a negative is a positive. 6 times 5 is 30. So what I see is I see negative 1y squared plus 5y minus 6y plus 30, not 36. The negative 1y squared, whether I do or don't write the 1, it's the same as negative y squared, so I can rewrite that as negative y squared. And then the 5 and the 6y have opposite signs, so to combine those, I subtract the 5 and the 6, take the sign of the larger, and that gives me a minus 1y, and I bring down the plus 30. And whether I do or don't write the 1 in front of the y in the middle, it has the same meaning. So that foils out to be negative y squared minus y plus 30, which is identical to the original problem, so it's factored perfectly correct. So each of the problems between 15 and 30 are two-step problems. The first step is to either factor out a negative or factor out the greatest common factor. The negative or the greatest common factor is going to tag along and be part of the answer, but it won't impact the factoring anymore. And then after you've factored out the negative or the greatest common factor, you factor what's left in the parentheses. Let me do 20 because 18 is basically, it's similar to 16 and I'm getting short on time. Do my pen colors look different today or not? Still not? That kind of sucks. I got the Glam, the 80s Glam version of these Sharpies pens and figuring that would look different, but apparently they don't. So for this problem, there's a common factor. I'm not going to factor out a negative because there's not a negative written first, but there is a common factor that I need to factor out. Cindy, 6 is a common factor because each of the numbers 6, 30, and 24 are divisible by 6. I can write an equal sign if I'm being correct, but if I don't, I'm not going to take points off. I'm going to write a 6, and then I'm going to write a parentheses. Because the 6 doesn't have a negative sign, I'm going to keep the signs as a couple of pluses. And there's no reason to change the signs because I haven't factored out a negative. Now I'm going to divide each of the numbers by 6. In front of the y squared, I can write a 1 or no number because 6 divided by 6 is 1. You could have a 1 in front of the y squared or just write a y squared. You get a 30 in front of the y and a 4 from the 24. So factoring out a 6, I'm left with y squared plus 5y plus 4. That 6 is part of my answer, but it doesn't impact the factoring anymore. The rest of the work is just being able to figure out how to factor y squared plus 5y plus 4. The 6 that's the common factor is part of my answer, but it doesn't impact the factoring anymore. In factoring y squared plus 5y plus 4, my signs in my first should come for free, which are first are a couple of y's, my signs are a couple of pluses. And then I have to know how to turn that 4 into a 5. My lasts have to multiply to 4 and add to 5. And I can't go wrong because when the signs are both the same, you can change the numbers up and you can't put them in the wrong parentheses. And the lasts are going to be 1 and 4 or 4 and 1. So if you had 6 times y plus 1 times y plus 4, that's correct. I'll do one more just so you can have one more in your, let me do 28. Or you could have 6 times y plus 1 times y plus 4, or you could have 6 times y plus 4 times y plus 1. 28 is an odd problem. It probably doesn't really belong in this section, but I didn't know where to put it. This problem, there isn't a common factor. There isn't a negative written first. This problem is similar to problem 30. It's similar to 27 and 29. In order to factor, I have to have the square term written first. So I'm going to rewrite this problem with the y squared first. My rules for my signs imply that the square term is written first. If I write the y squared first, the 5y is not first anymore. It needs to have a sign. Because it doesn't have a minus sign, the sign I'm going to give it is a plus. And I'm going to write the 14 with its minus last. Now I'm going to factor this. There really isn't a common factor to factor out, nor it wouldn't make sense to factor out a negative. There's negatives not written first, so I'm not going to factor out a negative. There's no common factor. So I'm just going to factor this. So this doesn't really belong in the section because there isn't a common factor, but it still can be factored. And the reason it's in this section is because I couldn't factor it how the problem was written. When I go to factor this, my signs in my first are supposed to be easy. My signs are plus and minus. My firsts are a couple of y's. And the lasts are going to be 7 and 2. They multiply to 14, subtract to 5. And that's going to be 7 and 2. Because the 5 is plus, the 7 has to be plus. So the answer to 28 should be y plus 7 times y minus 2. I might have shorted you a bit on the problems between 15 and 30. So after you do all the homework tonight, if you need to see some more of those problems, because I really skipped through the problems between 15 and 30, ask me. I've got plenty of time tomorrow to do these problems. If if you're feeling underwater as you're sitting in class, the best thing you could do tonight is watch the video over section 1.3, so that my lecture won't seem so overwhelming. If you're not feeling overwhelmed, then watching the video probably won't make any difference. But if you're really starting to struggle, factoring is hugely important. Watching the video before class will probably help you tremendously. All right, sorry for being behind.